Namaste and good morning, everyone. I, Ritika Gupta, Senior Assistant Director at IMPRI, Impact and Policy Research Institute, Prabhav Evam Niti Anusandhan Sansthan, extend my heartiest welcome to you all to IMPRI #Web Policy Learning. We are here on the second day of the 3-day online certificate training program on disaster resilient waste management for sustainable spaces. This program is being organized by National Institute of Disaster Management at Ministry of Home Affairs with Government of India and Center for Environment, Climate Change and Sustainable Development at IMPRI. I would now like to request Ms. Nishi Varna, who is Research Program Officer at IMPRI, to take the proceedings forward. Ma'am, over to you. Thank you.
Thank you, Ritika, and very good morning to everyone. I'm Nishi Verma, Research Program Officer at IMPRI, Impact and Policy Research Institute. I hope that you all and your loved ones are keeping safe and healthy in these difficult times. I welcome you to day 2 of 3-day online training certificate program on disaster resilience, waste management for sustainable spaces, jointly being organized by National Institute of Disaster Management, Ministry of Home Affairs, Government of India, and IMPRI Center for Environment, Climate Change and Sustainable Development, New Delhi. Disasters often generate large quantity of waste that threaten public health, hinder rescue and reconstruction efforts, and may significantly damage overall recovery efforts and negatively impact the environment. Safe handling, removal, and management of disaster waste are therefore important issues in disaster response and recovery. Unfortunately, current disaster waste management practice often involves either no action or improper action. Integrating disaster waste issue is a critical component which requires a fundamental shift towards a model that not only strengthens the response to crisis, but also learns and adapts in order to anticipate and act before such waste is garnered. Since Indian cities are experiencing a population explosion due to both migration and natural increase, hence technical know-how needs to be stitched onto social systems to sustain and maintain initiatives. Recognition of local risk, including everyday risk emanating from environmental degradation, needs a wider understanding by stakeholders at all levels. This 3-day online certificate training program aims to do this. The patron for the program is Major General Manoj Kumar Bindal, Executive Director, NIDM New Delhi. Our conveners include Professor Anil Gupta, Head ECDRM, New Delhi, Dr. Simi Mehta, CEO and Editorial Director, IMPRI, Impact and Policy Research Institute, New Delhi. We will also be joined by Dr. Indra Khurana, Senior Expert, Water Sector, who will also be moderating the session. I'm sure you all must have gained a lot from yesterday's session with our experts for yesterday's session, given by eminent panelist, Professor Anil Kumar Gupta, Head ECDRM, NIDM, New Delhi, Professor Shyamalal Mani, Senior Advisor, Wash and Waste Management, Public Health Foundation of India, and Mr. Harshit Bharde, Director, Swachh Pune. And before starting today's session, I would like to share with you the housekeeping announcement again. Please join the meeting on time and ensure at least 80% attendance of the 3-day online training course for obtaining certificates. There is allotment of 15 to 20 minutes for question and answers after each lecture by our eminent experts, and the questions will be moderated by me to ensure that they are answered in the best possible way. Hence, please feel free to write your questions on Q&A box only and not on chat box, posting it by your name and not as an anonymous attendee. Also, please keep the questions precise and refrain from making any general comments to save time and learn more from the certificate training program. About the certificates, I would like to clarify on that. First, you will be receiving a feedback form, and after the end of the program tomorrow on your email IDs. And after filling the feedback forms, you will be receiving the certificates on the same day. The videos are being posted on our Facebook and YouTube channel, whose details will be posted here. Now, I would like to invite you to our first speaker, Dr. Brajesh Dubey, who is Associate Professor at Indian Institute of Technology, Kharagpur. Dr. Brajesh Dubey is an environmental engineer, educator, researcher, trainer, and consultant in the area of environmental engineering, sciences, and health, presently at IIT Kharagpur, India. His interests include integrated solid and hazardous waste management, environmental risk, and exposure assessment. Dr. Dubey has worked with several government agencies in many countries on various environmental projects and has co-authored more than 200 publications in his area of expertise and has presented at several national and international conferences and has assisted United Nations and World Bank as a specialist in environmental projects in emerging developing countries. Presently, he is visiting Melbourne, Australia as an Endeavour Executive Fellow, Department of Education and Training. Australian government working in the area of sustainable engineering, integrated waste management, and circular economy. I invite you, sir, for the session of disaster management and welcome, sir, to IMPRI # West Policy Learning, and over to you.
Thank you very much. I was in Melbourne, but I'm back. That was actually last year. So maybe I forgot to give the updated bio. I'm sorry for that. So let me share the screen. Okay, so I think you must be able to see the screen now.
Yes, sir, it's working well. Please go ahead.
Okay, so we'll be talking about disaster waste. So I will start with kind of general, what we say disaster waste, what do we mean by that? What are the different disasters that we are talking about? In fact, if you look at this whole exercise of this like a big picture program, I think I was looking it up on the internet. And I think India is India is a leading country who in this area in terms of getting the discussion going in terms of disaster resilient waste management. And the first thing was that Gujarat earthquake was kind of the trigger point. Of course, it happened much later. I think 3 years ago, our Honorable Prime Minister launched this program, which is a UN supported program, but it is kind of outside the UN, but it is a UN supported program. So within that ambit, we are talking today. I had a chance to look at, I could not attend yesterday because we had some PhD presentations here, but I did went through the YouTube videos. So I see Professor Shyamala Mani here. I saw her like in Guwahati a couple of years ago for a conference there, and didn't get a chance to meet. Maybe after pandemic we'll meet more often. And so I'll a lot of learning from the yesterday's program. So you will see some continuation there, some different aspects, some different viewpoints as well. So let's get started. So when we talk about this disaster, whether we talk about at the national level or the international level, there are a variety of things which happens. Like you will have earthquake, there could be drought, there could be flood, there could be cyclone, landslide. So if you look at on the left-hand side, it's basically it's a percentage of occurrence of natural disaster by disaster type. Flood is around 43%. That's the number one, which if you look at the international disaster that we look at. Flood is 43%, then we have volcanic activity, we have wildfire, drought, landslide, extreme temperature, earthquake, storm. So those are different disaster type. Or if you look at percentage of land affected hazards in India, just focus on, if you look at the land affected hazards, then again we have earthquake, drought, flood, cyclone, landslide. So pretty much different activities which happens, and they do generate a lot of waste material. And many times the waste coming from this disaster is very nasty kind of waste. Nasty means highly mixed waste. So if, God forbid, if there is an earthquake in the building which I'm right now, we have, like if I just see around here, we have mercury lamps, we have a fan, we have the AC unit, we have different furnitures, different paintings on the wall. So if you get this waste to segregate it out and try to do recycling and resource recovery, it's a bit challenging if you don't plan it for properly. So we do need to have proper disaster waste management plan. And in fact, NDRF, that National Disaster Force, which is there, they had a workshop 2-3 years ago. I was attending that workshop where they were talking about development of how to respond to a disaster. Like our disaster response team is very, very good in terms of the way they do their job, the paramilitary force that we have, which do the job for us. But in terms of managing the waste, still it is a bit like the know-how is needed. Like a lot of training and other things are needed over there as well. And these disasters are creating a lot of economic loss. If you look at in terms of different loss that is happening in terms of different disasters, storm 38%, these are again global, 29% from the geophysical activities, drought around 4%, flood 25%. And if you look at in absolute losses, America, because of all their, they get a lot of hurricanes and tornadoes and other stuff. So that's, they get like almost 46% of the global loss by continent is from Americas, but Asia is also not far behind, around 37% of the loss. So we lose a lot of stuff. We have seen that from the disaster that has happened in India recently. We had Yash in Bengal and also in Odisha. And before that, we had Amphan. And prior to that, we had Chennai flood. We had like a massive like flood and landslide in Uttarakhand and that area like few years back. So from time to time, we are seeing these disasters happening. And I think Professor Gupta was mentioning yesterday about the climate change and all, and these are also triggering more and more of these activities. So we are seeing the frequency of these disasters, especially natural disasters, are going up. So if you look at the type of waste, because since we're talking about the waste management, so if you look at the different, here in the table, what you're looking at is your different types of disaster: hurricane, tsunami, tornado, flood, earthquake, wildfire, or ice storm. And these are the waste stream, where vegetative waste, construction and demolition, which will be essentially disaster debris. The other name is called disaster debris for them. Household items, household hazardous waste. We do keep a lot of things in the houses, like used oil and some kerosene and all those kind of things that you have, the different types of stuff, which do classify under household hazardous waste. White goods is our, all those like appliances, your refrigerators, your washer, dryer, and all those things, they come under white goods. They are called white goods because if you remember earlier, they were all used to be white. Now they come in multicolor. But they all used to be in white. Like if you look at the old refrigerators, they used mostly to be in the white color, especially in the Western world, they will be in white color. So that's why they are called white goods. That is nothing special about that. Then there could be some soil, mud, and sand, vehicles and vessels. During that Uttarakhand, that lens we saw on camera, because of these days, everybody has mobile phone with nice camera. So we saw some videos where all the vehicles were getting into the river, and then possibly it went down to several kilometers. So vehicles and vessels in the ocean, vessels also gets in any sort of disaster. They may go under the water as well, and they may go bad. So there are the large domestic electrical goods. Those are the fridges and washing machine. That's called white goods. So you can see the variety of items present there. Putrescible waste as well, which can degrade. So you can have, and these are the, if you look at the different disasters, so you can see this acts pretty much everywhere except in few boxes. So we do get most of these items coming up in our waste stream. And they are also essentially what we get for most of these parts is essentially what we are getting into our regular solid waste stream as well. When we talk about municipal solid waste, or construction and demolition waste, or certain industrial type waste. So we do get these stuff there too. So it's the nature of waste is more or less the similar. What happens is during the disaster, suddenly you have a huge quantity coming up. Now, and also you have a highly mixed nature of waste. How to handle that? Construction and demolition, relatively easier. You can like the wood pieces, concrete pieces, those things can be taken out and can be recycled and can be salvaged. But some of this stuff, like household items, especially when they are all mixed up together, with all like gets basically very dirty. So even if to salvaging some of this stuff from there becomes an issue. So we have to have some sort of mechanism. That's what I will try to talk about. That what kind of mechanism is needed in terms of managing this disaster debris. So it's the basic, so if you look at the example, this is from Japan. Japan, as we know, that they get a lot of disaster related stuff happening in the country. So in terms of, they have come up with Basic Disaster Countermeasure Act and Waste Disposal Law, where they have a disaster, before disaster, have a disaster waste management plan. And I think we also do have now that a disaster waste management. At least I saw somewhere some document as part of that workshop that I attended. There was some few pages of document was there. I'm not sure whether we have that in like already propagated and all that. I have to look it up. Maybe Professor Sambyal may know about that. So, but like I was trying to look it up yesterday, but I could not really find it. So, but doesn't mean that it's not there. It might be there. So we do have to have a disaster waste management plan so that people should be aware that what to do, because that's what happened. Like you get so much overwhelmed with this huge quantity of mixed garbage. Now, how we can handle it? What are the best management practices? What we can do in terms of handling it? That type of training is also required, and especially in the disaster-prone areas. Disaster-prone areas, our executive engineers, our assistant engineers, our workers working in the waste disposal, waste management field, they need to have this kind of training, because this waste is slightly different than municipal solid waste. More or less, they are the same, but it's still they are different, and it's still because you have this huge quantity coming up. So that becomes a problematic in terms of managing these waste at one particular time. So there are, they have come up with disaster waste countermeasure guideline, action guideline plans for larger scale disaster. So after disaster, they look at the implementation plan as well. And after every disaster, we have to learn from that disaster and then plan better for the next one. Because this is a dynamic process. It's not that every disaster teaches us something different. So we have to learn from there and try to come up with a better like knowledge for the next time. So continuous issue and progress of disaster waste measures. You cultivate knowledge from and reflect on a small scale disaster. Try to look at the like a system with progress. Like you can look at a wide scale coordination. Because you need to have basic waste disposal, public clearing policy. You have to have some grants to help some of this stuff. Invest whether 3 R's being implemented. Can we do the resource, the reduce is possibly not, you cannot really reduce much, but can you do recycle? Can you recover? Can you do reuse of the material? Sharing experiences. So if we had disaster in our area, whatever lessons learned, that lesson should be shared with all other areas of the country, or maybe globally as well, but at least within the country, in terms of how we, what are the things which work for us, so that others can learn from it and then come up with a similar response, or maybe better response there. So that this kind of basic systems of execution need to be ready, especially for pre-disaster preparation. And that is awareness among the residents. So those are also required. And it's a, as I said, it's a learning in process. So you need to have different, you need to have national organizations involved, regionals, volunteers, consultant, industry, construction industry, chemical plants, waste management industry, recycle industry, municipality, all the different stakeholders has to come on board. Then only you will have a perfect response to a disaster in terms of managing this disaster waste. So here also it kind of tries to tell you, again, having a pre-disaster management where you have preparedness, mitigation plan, disaster has happened. After that, have the debris collected properly, transport, reuse, recycle, landfill, dispose, demolition waste, reconstruction waste. So we have reconstruction, rehabilitation, relief, and all that. So, and while during the, as part of the disaster plan, we also have to have proper building code. As you know, those of us who are working in the construction or civil engineering, we know that if it's a earthquake-prone area or if it's a seismic zone area, there is a they have to follow a certain building code as opposed to the other areas. So those are also has to come in picture. We have to have emergency training, warning systems, evacuation plans, public education, and all that. So this is again another I will show you some examples of how people have responded in terms of disaster. So in terms of it's a Japan case study where say they had they set up an area where all this disaster waste is being collected. I was in US right after Hurricane Katrina. In fact, I was there before Hurricane Katrina as well. But right because I was doing PhD at that particular time in Florida. So after Hurricane Katrina, we did travel to New Orleans, and I'll show you some picture from there and a brief study that we did over there. So, but this is and if you plan meticulously, say if you look at this, they have a designated area where the debris was brought in. So the debris are brought in either by the individual house owners, or it is coming in the trucks, or individual house owners are also bringing the debris. They're dropping off at the designated drop-off location. These are not the dump places as such. These are all secured, designated, as you can see the fencing and all that. It's a secured, designated place where it got dumped. And they are putting the different categories, as you can see that all the electronic waste is on some, metals containing waste on some. There will be, of course, there will be some mixture which will be sorted out. But at least from the physical point of view, you can put some sorting system, sorting places. And here they had like wood or like carpets and other stuff in there. Then furnitures and others like a broken wood here. If there is some good furnitures, they are here. So those are all put into different categories. Now it becomes easier to salvage these materials, because if they all come together and get dumped in one place and now you have a heap of garbage, just to manage that becomes an issue. If we can plan it a bit better, if we can segregate it, and we of course we need some land for it, but this planning has to happen before the disaster. Because if something happens, these are the designated area where we will bring out waste. These are the where we'll try how this is how we are going to segregate. So that once the waste comes in, you can have a system in place where you have your entrance. There is a debris, glass, metals. As you can see, the pictures are similarly. The layout has been shown here. So the vehicles comes in, they drop off at different things at different locations. The vehicles goes on. So and once it comes there, then you say segregate it. You do the primary waste segregation, secondary waste storage, and you try to once you get these materials out, you can go for whatever can be salvaged. You salvage those, recycle those, and then finally, what cannot be done has to be finally disposed in a lined landfill. So in terms of, and then public information program has to be there. So establish a public information to handle disaster waste management. Develop contact list so that people should know whom to contact. And they should be working. Not unfortunately, say for example in India we have the e-waste rules already implemented. There are designated e-waste recyclers. Also, you can find their names, but many times you call them, nobody picks up the phone. So that should not happen. So we should have a proper contact list for the public in terms of hotline for public call, coordinate jurisdiction, advertise recycling diversion program, identify the target groups, provide this information to public, and develop public information campaign. And those are very, very important. So similar example over here. This is from another study. I'll just skip it for the interest of the time, but the same thing. You have this construction and demolition waste and different kind of waste coming in, get shredded out, and then things getting recycled from these disaster places that you see. Very quickly, I'll just show you about this work that we had done long back. This is actually when I was still doing my PhD, but since we're talking about disaster debris, I thought I should talk about this. This was after Hurricane Katrina. We were looking at, it's in US and many countries, they use a lot of wooden material for construction. And those wood which actually comes in contact with the soil are treated wood. And in terms of treatment, they used to use chromated copper arsenic. This chromated copper arsenic was being used in terms of treatment. So arsenic was there. So we wanted to find out, and we saw that as part of this disaster debris, as part of the demolition debris, there was a significant amount of this arsenic treated wood was being disposed. So, and my PhD was focused on arsenic and chromium fate and transport in the environment, especially from the waste disposal sites. So I was interested to know how much arsenic is actually getting into the environment from this disaster debris. So we did this study, which actually got published in Environmental Science and Technology, which is actually considered one of the top journals of our field after Science and Nature. This is, I think, this is the journal in our field. So it was also made into the cover page there. Arsenic treated wood in Hurricane Katrina. There were a lot of news articles being based on that as well. So as if like in Katrina's arsenic threat, Katrina results in increased arsenic level. So those things were there. So what we did essentially was this is this lower 9th Ward area and the other areas in New Orleans where we had most of the damage. Some of you, if you're familiar with Hurricane Katrina, you know that these are the flood levels. As you can see, the different colors showing you the different flood levels. So we went there and did the sampling, and we had this handheld XRF gun. This is $30,000 US toy. Okay, so this is a $30,000 US machine. It's a handheld XRF, which we can use to find out whether this, all these pieces that is coming, whether they have arsenic or not. And then we could correlate with the numbers that we get here with some correlation factors which we had developed in the lab, and we can get the arsenic number, how much arsenic was going out there. So we did the samplings at 7-8 different locations. At every location, minimum 30 samples, minimum 30 hits for arsenic treated wood. And then we found out what was the average arsenic coming out. And total, it was estimated that 1,740 metric tons of debris generated in Louisiana and Mississippi in terms of total arsenic. There was 1,740 metric ton of arsenic went into the environment. So later on, few years down the line, if you see groundwater arsenic pollution, they are one of the source to be this in those areas. And these you can see the disaster debris. And this was almost a month after the disaster. So it took a lot of days for cleanup there in terms of disposal. So just very quickly, okay, we have around half an hour more. So maybe around 10-15 minutes more for me, 10 minutes more. So like why we are even talking about, when we talk about all these disaster debris or we talk about waste management, we are talking about the environment in general, what is the big picture? And I try to put things in a big picture scale, that what is the importance of all that? See, ultimately our goal is what? To protect this earth. Why? Because we are selfish. We are not protecting the earth for the sake of the earth. We are protecting earth because of us. We want to be safe. We want that our future generations should be healthy. That's what the inherent principle here. So if you look at this earth is 4.6 billion years old. That's newer research suggests that it is actually even older than that. Now, if you take the age of the earth and put it in a 24-hour scale, why 24 hours? Because there is a 24 hours in a day. And in that 24-hour scale, 1 second is 52,000 years. So if the modern humans, this is as per railway timetable, the timing has been given here. So after 12, 13, 14, 15, 16. So modern humans are actually, they come on existence at 23, 59, 56. So that means we have existed on this planet for just 4 seconds. Only 4 seconds if you look at the entire age of the earth in a 24-hour scale. And in this 4 seconds, we have done so much of damage to our soil, to water, to ocean. I'll show you some ocean study as well in a minute. And so this is, we have created so much of nuisance for us. And that cannot continue. Like this is not, this cannot continue forever. See, there were many species before us. We have existed for only 4 seconds. Dinosaurs were there, and there were a lot of other species before. There are a lot of species today present. And say tomorrow, when I say tomorrow means after this thousands or millions of years, humans may not be there on this planet. We don't know. We were not there forever. We may not be here forever. But as human, we have so much of ego that we think that we have conquered everything. For a year and a half now, this tiny virus has showed us, जैसे अगर हिंदी में बोले ना हमारी औकात क्या है, वो उन्होंने दिखा दिया. So that's like what we can actually do. There have been some studies which says that if you take all the viruses of the world, which is there, this COVID-19 virus, if you take all the COVID-19 virus of the world, put it in a Coke can, which you get from Domino's or Pizza Hut, after when you buy a pizza, you get that Coke can. Then if you put all the viruses in there, still the top 25% will be empty. So बस उतना ही virus है. और उतने virus ने हम सबको नचा दिया basically. Like I was also affected, my wife was affected. We lost some, like in my extended family, we have lost 2-3 people. So this is especially in the second wave, which was really bad. So it has created so much of problem for so we have to work with Mother Nature. We have to make sure that nature is protected. So in terms of, since we're talking about waste is one of the important aspects. When you heard Professor Syamla Mani yesterday, also Mr. Pandey, Harshit Pandey, he was talking about that Pune, and part of Professor Gupta's lecture was also related to waste. So waste is important component. That's why we are talking about in this 3-day training. So if you look at waste in general, this is talking about municipal solid waste. So if you look at the solid waste, 2.01 billion tons was generated. This is 2018 report of World Bank. And unless we do something, that number will go to 70, increase by another 70% to 3.4 billion tons by 2050. 2050, I will be like in 2050, I'll be in our late 60s by that time. So I'll be probably, for me, it's a job security, isn't it? For me or Professor Syamla Mani and others who work in waste management, we are all garbologists. So for us, it's a job security, but that's not, that's like, it's that I don't want that to happen. It's we will have job security anyway, but we need to reduce this waste. So we cannot have this much amount of waste coming out, and we need to manage this waste properly. So if you look at the waste, what is there? This is again, this is again global numbers. As you can see that metal is 4%, we have glass, we have plastic around 12%, glass is around 7%, then paper and cardboard around 17%, food and green waste 44%. So this is, that's your, in terms of different components out there. Metal can be recycled, glass can be recycled, most of the plastic could be recycled too. There are, but if you cannot be recycled, we can do resource recovery from plastic as well. And paper and cardboard could be recycled. We can, food and green waste can be composted or whenever be digested. So, but then what is the problem? Why it is not happening, say, for in a country like us? It is not happening because everything is mixed up together. We are still not doing proper job in terms of the source segregation. And since we are not source segregating it properly, everything mixed up, there is no technology for the mixed municipal solid waste out there. There are some which claim something, but I have seen that after a couple of years, they also don't work. So, and that I'm talking about from the different countries, working in several countries on waste management issues. You need to do source segregation to have any effective waste disposal. That's what I was trying to highlight in this Economic Times article, which I wrote almost 3 years ago, that for effective waste disposal, segregation is the key. Segregation not only at the household level, but segregation also all along, where we're going all the way to the treatment plant, as well as also the disposal side. Right now, for example, here in our campus, we are segregating at home. We have been given 2 bins, we are segregating, but most of it, actually what we heard is that it gets, later on it gets mixed up. So if it gets mixed up, what is the point of segregation? So we need to have proper infrastructure in place. ULBs need to have proper infrastructure so that they can keep this waste segregated, and then only you can do resource recovery, then only you can do waste to wealth and so on and so forth that you hear from time to time. Why also it is important? See, we are talking about housing for all. We are talking about lots of resources that we need to have. I'm talking about solid waste in general, not only municipal solid waste. We do have finite resources in terms of metals, minerals, and all that. We don't have infinite resource out there. It's a resources are finite. So when we have finite resources of metals, minerals, they are becoming more expensive, and the extraction is also becoming more difficult. So what we need to do is we need to rely on secondary material. And if you, for the secondary material, where they will come from solid waste, not only municipal solid waste, but other industrial waste, mining waste, all those different. For example, we are looking at rare earth. Recently, last week, there was an article in several newspapers, several news websites, talking about that China's dominance in terms of the rare earth for electronics and all those renewable energy supplies. Now, like 90 to 95% of those metals those are critical metals are coming from China. We are producing, we have so much, we have I should not say so much, but we have a decent amount of that material, those critical material in our waste sources. We need to try to recover those from our waste material. So it's inevitable. We have to do that. It's from a material safety point of view also, it's very, very important for us to do that. So as you can see over here, the projected numbers are much higher for non-metal minerals, biomass, fossil fuel, metals. So we need to, in terms of fossil fuel, we need to come up with waste to energy in terms of biogas and incineration. Again, I'll talk about that in a minute in terms of incineration. So whenever you develop this waste management plan, first of all, for any city, you need to have identify the need. What type of waste are currently generated in what quantities? So not only you need to have a very good understanding of the garbage. So when I say that very good understanding, you need to know what is the biodegradable fraction, what is the combustible fraction, and those sampling has to also happen at realistic places. Many times I have seen several DPRs. I have reviewed DPRs for a few state governments, actually quite a number of them, and see that samples have been collected at individual houses. Now this individual housing sample is good, but see, this waste is going to the primary collection center where the animals will come and eat all my biodegradable. Rat pickers will come and take out all the recyclables. So unless my collection system is fixed, if I have these kind of samples, they are not giving me the true picture of what is the garbage is going to end up at my disposal site or a treatment site, isn't it? So we have to look at the waste, how it changes, how the waste composition changes along the way it moves in the supply chain. Otherwise, you will rely on the house data, but what is the garbage coming to you is very different, and then you will have problem in terms of your plant not working, and it is happening today. So, and we need to know very clearly how much is biodegradable if I want to go for composting or anaerobic digester, how much is combustible, what is the calorific value, what is the VS, what is TS, what is the CHO-NS analysis. All those things needs to be done, although they are costly, but has to be done. If you want to save cost long term, if you look at the life cycle costing, you will find that these are actually not that costly anyway. So, because why they are important, say if you don't know the waste properly, you will recommend a technology which is not going to work, and then you are losing a lot of money. We end up making so many white elephants in the country, and we cannot afford to do that. So that's the reason why knowing it's very important. I always give an analogy. Say if I'm critically sick, and if I go to a doctor and the doctor doesn't do blood report, urine report, or any X-rays or CT scan, whatever is required, no diagnosis, he writes a prescription. Those kind of doctors are very rare today, who can just put my stuff, like look at my pulse and understand what's my problem I have. They have to do proper diagnosis, isn't it? If they don't do proper diagnosis, you will be uncomfortable. But and if you write a prescription like that, but that is what has happened in waste management sector, is that people were just have a guesstimates, not proper data, secondary data, and data also not data quality is questionable. But people are writing big DPRs, and those DPRs and many of those projects fail because they are based on bad quality data. Having bad data is actually worse than having no data. I would rather have no data than having a bad data, because bad data gives you a false sense of security. So in terms of, then once you identify the need, you review the existing system, you review existing regulation, organize framework, establish objective, what is your short-term, long-term goal? All these planning, if you look at big cities around the world, wherever the waste management is working properly, or even at the state level, you will find they have a 25, 30-year plan, and which they revisit every 5 years to see what is working, what is not working, and what should, in terms of like how to fix what is not working. So it's a learning process. It's a dynamic process. It's required a lot of engagement of all the different stakeholders. It cannot be, you need to get different stakeholders on the table. You are getting garbage every day in the morning from individual household. So if those individual household is not with you, you will have problem on a daily basis. So you have to get them on board and make them feel important as well. They should know what is going. So a lot of from bottom to up rather than top to down approach needed here, in my view. And then education, public participation, outreach. So once you have established objective, identify what are the potential components, you compare the option, develop the plan, implement it, and then evaluate in a regular interval. So gradually we will be there. Like we have to work in a due diligent manner. As I said earlier, once you understand the garbage properly, you can choose one of the different technology which is out there. It's Each one of those technology has pluses and minuses. And it all depends on what is there in your garbage. These are all technologies, these are all processes. And if it's a process, it needs a good feed, which is relevant for that process. If the feed is bad, that process cannot do any magic. Your output will be bad, your plant will suffer. So what we need to work on is to make that feed proper. And based on what feed I have, that should decide whether I can go for composting, anaerobic digestion, of course, all economics as well, like whether you'll be able to sell the compost, whether the compost will be sellable. It has to be self-sustainable as too, because the government subsidy might be there today, tomorrow it may not be there. So we should focus on making it more and more self-sustainable. And then also in the thermal conversion, incineration, gasification, parallel, these are mostly for a specific kind of waste. But incineration as well, you need to know whether you have enough calorific value. If the calorific value is not good enough, it cannot be one size fit all. With all due respect to NITI Aayog, they have come up with a report which says that waste to energy is the solution of waste problem in India. I respectfully disagree, because it may not be, because it depends where you are. Say if I'm in, for example, in Kharagpur right now in West Bengal, it has been raining for last 7 days. My collection trucks are all open. All the garbage is getting wet. How it will get incinerated? So what is the calorific value there? Same thing for Kerala, same thing for northeastern states. So it's not that what will work for Delhi, Rajasthan will work for other parts. India is very big. Waste management is a localized problem, needs a localized solution. Yes, there should be some guidelines from the top, but there has to be a lot of flexibility at the local level as well. You have to look at the local economics, whether things will work at the local level, whether you have the market for those products. If you don't have, what is the point of making those? Because unless it's economically viable. So, and you see that happening. I think Swati will be here later on talking about that. Probably she will show you this slide again. Swati Sambyal, who's worked for like a UN Habitat, I think now. She was earlier with CSE. And then you look at here, this is 2018 document to burn or not to burn. Operational plant 69 megawatts. Under construction 84 megawatts. Proposed 383. Non-functional 66. Now, why these are non-functional? What really went bad with them? Are we repeating the same mistakes here? In 10 years from now, will we have a bigger number here? We have to investigate. See, we cannot just keep an eye shut, because these are your and my taxpayers' money. And on top of that, these are national resources. So why we should waste them? If it works, great. But why this 66 megawatt is non-functional? There has to be a critical evaluation of that before we kind of go into all these buildings. There has to be a critical evaluation, so that we should not repeat the mistake and keep on many plants be shut down. As you can see, there are such plants pretty much everywhere in the country. So those things are very, very important. And very quickly, next, give me another 5 minutes. Just very quickly, I'll show you 2 projects that we have been working on. We finished this now, which was on National Geographic. This was a plastic sea to source project. We were looking at how much plastic is getting into River Ganges because of the mismanagement of municipal solid waste along the river. So we had a boat going all the way the river from Bangladesh all the way to, we could not go to Gomukh, so we went up to Harsil, slightly above Rishikesh. And we did this twice and collected lots of samples all along it. And then we also collected the city level samples at these different locations in India as well as in Bangladesh. The report is already there on National Geographic website. You should be able to download it. If you don't find it, you let me know. I'll send you the report. So basically, we found that it's still a considerable amount of waste, especially plastic, is getting into the river Ganges, which is making way to Bay of Bengal. This was our team. It was mostly led by ladies. It was a lady-driven team. As you can see, we are only 4 male members and all ladies there. It was like a lot of field work, but these were totally, they were all into it. And then we had a lot of fun all along. I could not be there for all the time, but my students were there on the boat all the time on the expedition. I was joining them back and forth from time to time because of my teaching and other commitment. Then other work that we have been associated with is a high-level panel for sustainable ocean economy. This is driven by World Resource Institute, led by UN Special Envoy for Ocean, Peter Thompson. And as you can see, many countries were involved in that, especially the countries which have a lot of things to do with ocean economy. So unfortunately, India was not part of that, but there were a lot of other countries here. So we came up with this blue paper where we are looking at how to address plastic pollution in the context of already stressed ocean. See, we talked about, when we look at ocean, there are a lot of talk and activities going on in terms of plastic pollution in ocean. Also, it is going on plastic pollution on river, but all these are starting on land. So that National Geographic project that you just saw was looking at actually how to actually prevent this plastic to get into those rivers and ocean. Because unless we tap it, we will keep on cleaning the ocean forever. So we have to tap the source. So the source is the mismanagement of municipal solid waste, mismanagement of plastic waste. See, plastic as a material is not that much of a problem other than single-use plastic, but plastic waste is a nuisance if we mismanage plastic waste. So here we were looking at how the ocean is already stressed, but how we can look at in terms of solving this problem. We had authors pretty much from all around the world. We were top three, we were the lead authors, Jenna from US, Ali Moss also from US, and myself from here. And we had authors from Indonesia, South Africa, Australia, Vietnam, China, UK, Australia, Chile, and a lot of other places too. So what we found is very quickly, kind of just a snapshot, 5 to 13 million metric tons of plastic go into the ocean each year. That's like one dump truck of plastic per minute. 13 billion per year in damage to marine environment. 3% of ocean plastic is only floating. So you can just take, if you look at the surface, you can only clean 3%. 97% is already in that water column and also in the sediments. 1.9 million microplastic per square meter on the ocean floor. So we have to, and in terms of sources of ocean pollution, not only from plastic, from all the sources, you can see variety of activities that we do on our day-to-day basis, industries, marine and recreational, cruises, shipping, oil platforms, all those contributes to ocean pollution. Some has plastic, some has not, but all these contributes to ocean pollution. And from municipal sources, agricultural sources, industrial and maritime, we have microplastic, macroplastics, pesticides, nutrients, antibiotics, heavy metals, industrial chemicals, oil and gas, and they are all leading to negative impact in terms of ocean health, and also, as you saw, 13 billion cost, impaired productivity of fisheries, loss of seafood supply. So a lot of impact is there. So how to stop? How to stop ocean pollutants and plastic? So we looked at these 7 like infrastructure, improve wastewater treatment, stormwater, green chemistry principle, radical resource efficiency, recover, recycle, coastal zones, build local system for safe food and water. And we also related it to the SDGs, like so sustainable development goal. This document is not too big, around 60-65 pages. It is available for free. You can download it from World Resource Institute. If you just put blue paper and you put my name, you'll probably find it, or blue paper on plastic, you will find it there anyway. And it got coverage in a lot of international media in terms of Guardians and other places as well. See, these are all on the sustainable development goal. I think yesterday also one of the we talked about sustainable development goals, and you are aware of these. There are 17 goals, so ultimately we all are trying to work towards achieving this goal right now. Just very quickly, what is happening in our lab right now? What is the focus area? So we are working on our targeted, although we work on other areas, but our target is some of the big research projects we have right now is kitchen and food processing waste and yard waste, and try to get a lot of value-added products in terms of having more of a circular economy approach, where we can go for hydrothermal carbonization and make all these different value-added products from there. If you're interested, we can talk about it later. As part of disaster, see, this pandemic is also its kind of disaster. So we did some work on pandemic solid waste, which is 2 papers are published on that. One on the solid waste management in terms of during and post COVID-19 pandemic. If you're interested in this study, I'll be happy to share that with you. And also on plastic waste, because we are seeing a lot of plastic increase during this pandemic. So one was on general municipal solid waste, and then other was on just on plastic waste. And these papers are being cited quite heavily right now as well. So one thing we have to be like, whenever we make this environmental decision, we have to have a holistic approach. As you can see from the top here, This is a diesel vehicle having a lot of pollution. The gentleman feels so dirty. He goes buy an electric vehicle. He feels so clean. But if the electric vehicle uses coal-based thermal power plant as the energy, not the renewable energy out there. So what is happening is you just move the pollution from the roads to this coal-based thermal power plant. So it's not, we have not solved the problem, we have shifted the problem. So you have to have a holistic approach, having a life cycle approach whenever you make certain decisions. So if you want to learn more about waste management, this is one source. There are a lot of other sources out there, but this is a Ministry of Education, Government of India funded program. Through that, we have been offering this integrated waste management for a smart city. Smart city word I just put there just to catch more eyeballs, but it's not, it is essentially waste management, whether it's a smart city or not. Although I personally don't like the word smart, it should be more of a livable cities. Smart bonuses of the people think all Wi-Fi and digital and all that only. So in terms of this course have been offered, I think this will be the 5th offering of this course. Already close to 35 to 40,000 students have taken this course earlier. So on July 26th, it will start. I will share the link with Arjun and like IMPRI, and they will share it in their some newsletters or something as well. So this starts on July 26th. And there is a course on sustainable engineering. There's a lot of talk about sustainable development today. So what is that? What is the sustainable development goal, for example? What is actually the meaning of sustainable? How, as an engineer, we can contribute towards sustainability? So this is what we talk about here in this course. It's a 8 weeks. The previous one was the 12-week course. Again, this is also starting on July 26th. And this is the 3rd offering of this course on the online mode. And in January to January semester, we offer a course on plastic waste as well as a course on e-waste. So this is just for your information. So thank you for the attention. And I'm sorry, I think I took slightly longer time than I planned, but we have around 10 minutes for Q&A.
Right. So let me only, on behalf of everyone, ask a question. And that would be that with this pandemic, and let me also tell that with Brajesh, we have done workshops and his session all across the country to Kochi, Kolkata as well, all corners of the country. And sir has been doing these courses a lot. Sir, in your experience, you have studied in United States, also worked with European countries and agencies, Australia also. What do you see that what we are lacking across India for tackling this problem, especially in this pandemic? And so you really raised the question about infrastructure. When we see US or Western or all the advanced countries, now what they're doing is green infrastructure. They're taking more credit, more loan. Howsoever, we as a developing country need that most. How do you see the infrastructure and the approach which we are taking? What is lacking in the global and local experiences? Brajesh.
So see, it's a very big question. So I'll just try to say, in terms of pandemic, I will just focus more on, I'm not going to talk about pandemic management because that's not my expertise. I'll talk more from the waste management perspective. So waste management for pandemic, in fact, every country is struggling. It's not that some, wherever they have a proper infrastructure, they are able to do better. So as you said, Arjun, that if you have proper infrastructure, then you can build on that during this pandemic when you have an extra load, isn't it? This pandemic brings you an extra load of waste. For example, right now, a lot of PPEs, a lot of biomedical waste and those things coming out, waste coming from the hospitals, waste coming from isolation centers. Earlier we had those quarantines, individual houses. Say when I got positive, me and my wife, when we were positive, our waste was collected separately. But whether it was really getting into that biomedical facility, because we have some issues with local biomedical waste treatment plant from our hospitals. They don't come that frequently to collect it. So there is, again, if you talk about in terms of operational, it's more of an operational issues. Technological wise, I don't think we are inferior because the technology is, most of the multinational companies or their subsidiaries are everywhere in the world. So technological way, we do have same technical know-how, what is there in Europe or what is there in US or other places. The thing comes on having proper infrastructure. ULBs is still struggling to do, although 2016 rules, even before that 2000 rules was there, biomedical rule also be there for a long time. But we know that biomedical waste do end up at the dump site. I have seen that with my own eyes, that biomedical waste ending up. So because we don't have the capacity to handle even our regular biomedical waste. So when the pandemic comes, on top of that, what will happen? They will end up in the, you will see them ending up in those dump sites. There is no other, like what will happen? This is the most obvious thing to happen. So again, I'll say that again, building of infrastructure. When we say building of infrastructure, I'm talking about not only physical infrastructure, I'm also talking about like a intellectual infrastructure. Like physical infrastructure needs to be there, and as people needs to be trained as well. Isn't people need to be trained so that when we went on the field, many places when we're doing the DPR review, I went the field survey. The local people who are working with garbage, they don't know that burning of styrofoam is bad for them. The styrofoam is too bulky, usko burn kar do, फिर truck में बहुत जगह लेगा, उसको just यहीं पे burn कर दो. But they are not aware कि वो burn करके उसको inhale करेंगे तो उनके लिए खराब है. So those there is a lot of that intellectual if you look at capacity building. The engineers who are there, many times they are not trained in waste management. We don't teach waste management in many engineering programs. You can have a civil engineering graduate who never had a waste management course. So those kind of things we need to look at. So in terms of developing those that will be, I'll say, is what kind of difference we see between here and some of the developing countries.
Great. Thank you. Sir, if you can also stay with us, many questions are coming. But for the paucity of time, if you can stay so that we are here on time, and Swati ma'am has joined. Right.
Yeah, I see Swati madam. So good morning. Nice to see you.
Hello, Dr. Brajesh. Good to see you here. We always meet on platforms.
Yeah, we have to meet physically sometime as well, like after pandemic. So.
Absolutely.
After pandemic on IMPRI platform in a good hotel. Okay, so let us welcome our next speaker, Nishi ma'am, over to you.
So I would like to welcome our second speaker for the session, Ms. Swati Singh Sambyal, Waste Management Specialist, UN Habitat India, United Nations Human Settlement Program. Ms. Swati has worked widely. Ms. Swati has worked widely across India and Global South on resource efficiency policies and affordable decentralized waste management. Her research and implementation work has been instrumental in mainstreaming source segregation and sustainable resource management in Indian cities. She worked as the head of a program on waste management at the Center for Science and Environment for over 9 years and is presently working with UN Habitat as a waste management specialist. She has been on the Forum of Circular Economy formulated by the National Geographical Society and has been a part of national and international advisory committees on resource management. She is a minimalistic and strongly advocates for zero waste system through her social handles. Welcome, ma'am, to IMPRI # Web Policy Learning, and over to you.
Thank you so much for having me over to, this very, a few insightful sessions that I was able to hear, especially Dr. Dubey's presentation. I think what the speakers shared yesterday and for that matter, even today, it sort of makes my work a lot easier because I'll be majorly be focusing on what we can do to make things better. Of course, the challenges have been highlighted. Some of the best practices have been highlighted, but I want to keep, my focus in today's presentation on what could be some of the solutions that our cities could take to build more resilience around waste management, especially municipal solid waste. Pandemic has burdened our health infrastructure, but it has also amplified a lot of challenges around waste management. One, for instance, being how the frontline workers have been exposed badly. Many a times they don't even wear proper, PPEs and have been exposed to diseases. Second, being the increasing quantums of waste that has been reported across cities. Third, being an increase in quantums of plastics. Earlier an estimate was about 5 to 10%, but I recently with my team was in Mangaluru doing a survey on waste assessment for a city.
and the percentage of plastic was shockingly high, somewhere between 17 to 20%. So across cities, there has been an increase in single-use plastics and plastics in general. And I think this is also the time which cities could utilize. I mean, this is also an opportunity which cities could utilize to have effective systems in place, which are more resource efficient, which are more circular, which are more sustainable, but at the same time are income and wealth generating. Because presently municipalities spend about 60 to 70% of the expenditure in collection, transportation, and disposal alone. There is very minimal expenditure spent around processing, around sustainable solutions, which in the present time is the need of the hour. Now, why and how we could do and why a shift is required and what it would enable. First, I think we need to have effective waste reduction policies in place. If you really critique at some of the policies that are there, and now that we are also talking and debating on circular economy around resource efficiency, if we pick up our policy documents, none of them reflect circularity. So how do we build policies, bylaws, local strategies, state level strategies, which are circular, which reflect a city's or a state's or a country's motive to shift to circular solutions, especially around waste? Then how do we build zero waste communities and programs? Now, this marginally has been a concept, but this is also something that at city level is possible. You definitely can set up systems that could ensure 80 to 85% reinvent and reimagine the system. Also, side by side, working around a robust recovery infrastructure, having better incentives and more jobs, it would always come down to the economics of it, the economics of scale. So of course, if you're designing a system, if you want to make your city resilient around waste management, you need to make it income and wealth generating for people that are involved right from the lowest to the highest. And how do we at the same time empower citizens? Now, these are some of the solutions, but these are also some of the challenges that we face right now. Like these bullet points are also some of, the obstacles that we face while setting systems for cities around. Now, what we need to do and what we need to follow. First is, of course, learn to minimize, learn to rethink, learn to redesign. And here city functionaries and stakeholders and decision makers will play a very, very important role, which is to set systems which are around reduction and reuse over recycling, processing, or disposal. And then ensuring that there is maximum resource utilization, which Dr. Brijesh talked about at length, and also understanding that it's only what is unacceptable should go to a landfill or an incineration site. So high time we reverse the ladder and look at the best use and the worst use of the components. And I think that we are nowhere close to it right now. Of course, probably some cities are, but if you map them around circularity, they fall flat. Now, even before we talk about steps to adopt on sustainable waste management, and this is something, I'm glad Dr. Brajesh pointed this out, that we don't have data. We don't have robust data. We don't have numbers. Cities have waste generation data that is spanning, say, it's about 10 years old or 15 years old. And how do we plan based on that data? Of course, if you'll prepare an action plan or a strategy for implementation, it will fall flat, which even Dr. Brajesh said, because your numbers are wrong. And it's strange that no one realizes it. Numbers are really important. So I think it's about time cities go back to, the blackboard and start with inventorizing their waste, because there will be shocking findings. Now I'm sharing the findings which we did for a city in Karnataka, Mangaluru. And the survey happened, the entire month of April. We all were there with the local team. And UN Habitat has developed something which is called a waste-wise cities tool. It's a data inventorization tool, which basically helps cities to do a rapid inventorization over a span of 2 weeks, but also detailed inventorization at the same time. So a very robust mechanism that has been adopted to look at household waste generation, to look at commercial waste generation, to look at what is happening at the recovery and processing facilities, also to look at what gets dumped and what is the characterization when things, go to a disposal facility. And very strange, most of our waste composition studies for cities have been done on the dump site. To tell you that NOD gives you a true reflection of the waste management status for a city. So you really need to do a detailed survey, which for most of the cities, about 90 to 95% of the cities is not in place. Just sharing some of the findings before and after. So if you could see, after, based on what the city provided us, the data, and after doing the survey, the data that we got was, very different in terms of numbers on plastics, paper, a lot of dry waste components. Of course, wet waste estimations more or less, don't fall flat, because a lot of our cities generate, the maximum percentage from 48 to 60%
There is some connection related issues. I will line up. Meanwhile, Nishi ma'am, why don't you, if Brajesh is here, ask some of the question which was earlier highlighted. I will coordinate with ma'am.
Hello, sir. Hello, Brijesh sir. Are you there for the questions?
Did you lost me?
Yes, ma'am.
Yes, we lost you. No problem. Ma'am, would you like
from where can someone share, like, what was the last slide that I missed?
Should I share the screen?
I'm just sharing it. Yeah.
Okay.
Yeah. Is it okay?
Yes.
Yeah.
Okay, so Arjun, can you share? I was talking about the inventorization and the study. I mean,
yes,
I was here, right, when you
yes,
lost me?
Yes.
Yes.
So sorry for that. Yeah, so I was on the fact that, of course, before and after inventorization, the results varied. Just giving you a snapshot. And we did an inventory also based on income groups across households, commercial areas, and at disposal facilities. And of course, as you could see, the composition varied, not drastically, but you also can look at the consumption patterns, like what is a high income group society consuming compared to a low income group society. So I think in a nutshell, what I want to say is that these findings to make effective plans are really important today to set up better implementation systems in our cities. As you could see, this is a composition done at disposal facility site. And of course, it again has some minute findings. But if you do just a characterization at a disposal site, which has been the norm for many years now, you may end up getting wrong estimations. Also, we did, a detailed plastic leakage mapping. And it was shocking to find out that at least for this city, with a population of 6 lakhs, the plastic leakage was about 4.2 kg per capita, per annum, which as a number is quite huge. I mean, per person, that is the plastic leakages that you're contributing. So it's just one angle, but a very important angle that I want to emphasize on. And of our 4,400 and more statutory towns, we are not doing this part enough. And if we don't do this enough, we probably are making faulty plans, and probably many a times things don't work. I was seeing many questions like, okay, if this is the solution, why is it not working? Because that solution is based on a wrong number and estimation. How on earth will it work? Coming to what could be a roadmap to make our cities more resilient, especially around municipal solid waste system. A lot of points my peers have already shared, and I think these are also the points we've been shouting since 2016, since the solid waste management rules came. We've been saying at various platforms that mainstream segregation. Now, someone in the, I think, question asked, segregation is not possible, it's not happening, but I think it's high time that it becomes mandatory. Segregation in our cities today is optional. You segregate or you don't segregate, someone will still pick your waste and it'll go to, a facility where probably mixed waste processing is happening. And that's why a lot of your resources are being dumped. But it's high time, if your rule says that segregation has to be done at household level, why aren't we doing it? So high time that segregation becomes mandatory in our cities. If you have bylaws in place, put penalties, for non-segregation, and many bylaws have come up which even have that clause. But in spite of that, it's not happening. So I think for any resident or any generator for that matter right now, be it commercial, a bulk generator, or at a resident level, you can't keep segregation optional. You have to mandate it. And now there are various ways to do it. Having looked at various models, I think something very interesting that I found is being practiced in South Korea, wherein you're given bags of a fixed volume. If you give waste beyond that capacity, you will pay a higher user fee. So it's a disincentive also that if you generate more, you pay more. And if you generate less, you pay less. This is also something that's been practiced in a few Scandinavian countries. I witnessed it in Sweden, wherein if you segregate your waste into, say, 10 and more components, you pay a lesser user fee. But if you segregate less, or if you don't segregate at all, you pay a higher user fee. So I think it's high time we look into some price incentives that have, that have been practiced in a few countries. For that matter, also deep dive into what is happening in a few cities. Something very interesting I observed in Mangaluru, which was that if residents are segregating and going a step ahead and composting their waste, they have to pay 50% less property tax. Now that's an amazing incentive, and this could push many households to segregate at source. So I think ULBs need to push for incentivizing segregation at source. They really need to strategize it at source. And we're not sitting in an era where, there are no solutions. There are things happening around, but the problem is that they're not getting replicated. Also, behavior change has to be continuous, not intermittent. It's been observed in a lot of cities where you're trying to shift the system from, say, your usual collection to disposal to a more circular, resource efficient system. The only change, the only difference in such two cities has been that the behavior change element was continuous. Social engineering was continuous. But in cities where things didn't happen successfully, the behavior change element was intermittent. So I think this has to happen round the year. And this is where, involving other stakeholders becomes very, very important. Next is, setting up systems for effective collection and transportation. This is nothing new. It just means that if you are setting up a circular system and ensuring that, and you want to ensure that a lot of your materials would go into the recycling or processing value chain, you also have to set up collection and transportation to support segregation. It's been explored in a few cities. For instance, Surat, Indore, Nagpur, they've also gone a step ahead and done a route optimization map to ensure that there is less usage of fuel. So you allocate your vehicles in such a way so that minimum wastage of fuel occurs. It's more resource efficient and more optimized collection of waste. Also, MIS systems could be explored, wherein waste collection could be mapped on a daily basis, segregation levels could be mapped on a daily basis, and percentage of waste process could be mapped on a daily basis. This has been done by Vijayawada, where they have their own development management information system on their website, where you could track what's happening. And it's very important to make this information available to a user. I'm not saying that every layman will access this information, but for many who really want to shift to a sustainable system, a strange anomaly is that those avenues and options are not available right now. There was someone who was approaching me over, I want to compost at home. And that lady just couldn't find any avenue, in her city. And a better way of doing this could be, to provide information like this on a municipality portal, which also makes you well connected to, the generator, which presently, that bridge is still lacking. So in case we want to shift, in case we really want to complain, those systems, those grievance addressal systems are not in place for many of our cities. Probably there's just a number which always rings and no one picks it up. So high time that, corporations, by collaborating, say with NGOs, volunteer organizations, are more available for residents. Third, of course, and most important, is to set a system for efficient resource recovery. Now, of course, personally, I would favor decentralized infrastructure, but that would very well depend on the city. It may vary from city to city. A smaller city could definitely go decentralized, but for a bigger city, you can definitely adopt a mix of centralized plus decentralized infrastructure. And there are cities who have ended up saving a lot of revenue by going decentralized. Alapura being one. From a time that they used to spend about 70 to 80 lakhs a month on collection and transportation and disposal alone, when they shifted to 100% decentralized system, there were about 50 to 70% savings in municipal expenditure allocated for solid waste. For that matter, Muzaffarpur, a city in Bihar, for which I was deeply involved in setting up the model for about 3 years during my association with CSE, we observed that when we shifted from a system which was more collection and transportation intensive to a more decentralized system, the savings alone on CNT reduced from about 3 crores a month to roughly about 70 to 80 lakhs a month. So I think cities have really, observed that change, that when you go decentralized and when you shift to a system which is more processing incentive over CNT and disposal incentive, you end up saving money. In fact, you end up making money as a municipality, which is never the case with most of our cities. Many people ask, like, what do we do of quantums of compost, even if we go decentralized? I think composting is not the only option, as Dr. Dubey said. If you want to go a step above, I would rather suggest biomethanization and other energy intensive, approaches towards wet waste management, which probably are more circular. But even if you're composting, I think one system which Vadodara and Gujarat efficiently managed was that, creating these coupons, wherein households who were composting and they had excess compost, they could sort of exchange it with the corporation, and then they were given these coupons wherein you could go to a dairy or a Safal booth and exchange it for milk or, other grocery items. Also, something very interesting that is being explored in Bangalore, compost as a service in cities. So if I, as a resident, not want to compost at source because I have some inhibition and I don't want to touch my wet waste, there is a private vendor who would come to my house every day and compost for me, and I'll pay a minimal charge of 250 rupees a month. I think it's like a win-win situation, because a private entity is getting profited for setting up the system, and for ensuring that they take all the compost, and also give some compost to the household. The household is getting compensated because it's more like a value addition, right? Earlier, you were just throwing your wet waste, but now you're utilizing it at source, and you have some innovation. So there is some person, and if you can afford it, a vendor that is doing it for you every day coming to your house and taking care of the small nitty-gritties that are around composting. So in about 1,000 households in Bengaluru, this has been, piloted. And I think it's very, very interesting as a concept, as an idea, especially at metropolitans where people often complain that, well, we don't have time to do this. And also what I mentioned about having a list of vendors and technologies in place. These things are not readily accessible right now. And this is something which Kerala has done, wherein, there is a portal where you could go and access all technologies in place with numbers of vendors in place. So I think high time corporations, they all have a website, but high time that they provide these useful information at the perusal of various stakeholders, so that we could design systems where households and colonies or communities are also able to participate and communicate. So there is definitely that gap which is observed in few cities, but then a few cities have sort of worked well in mitigating the gap. This is something which, of course, as a system need to change. That, in most of our cities, there is an agreement signed between the corporation and the private party, which is your tipping fee, that is per ton of waste disposed, collected, how much tipping fee a private entity will get. But high time that the tipping fee element changes to processing. So of course, there's a lot of scope in changing our tenders, the tenders that corporation release and sign, which need to be more focused around processing and not around collection and disposal. This will highly shift the system to, to make it more processing incentive over making it more disposal incentive, because right now there is an incentive to dump waste. The more you segregate, many a times it gets mixed, because the higher the tipping fee will be. The more sorted your waste will be, the less the tipping fee will be. So if you sort of turn around your tipping fee around processing, there'll be more focus by all private entities and entities that are around processing, working around processing. They'll shift their focus to processing over collection and disposal. And right now, the focus is majorly around collection, like how much we can collect and how much tipping fee we can make. And tipping fees as high as, ranging from about 1,000 rupees to about 2,500 rupees per ton of waste. So imagine if South Delhi Municipal Corporation produces about roughly 2,500 to 3,000 tons per day of waste per ton. If a tipping fee, even keeping it as low as 1,500 rupees per ton, how much money is it? So the focus is totally around that money. And we really need to shift that focus towards processing, where municipalities pay money to private entities that come for processing, that, only if you process this much ton of waste, the tipping fee is what you will get, not for collection and disposal. And I think, like the West, have a landfill tax in place. It's high time that we disincentivize dumping. India has about 5,000 dump yards in cities. And of course, there's a massive work going around bioremediation and biomining and biocapping and whatnot. But I think it's not enough, because are we really changing those dump sites to integrated processing sites in the future? I think that should be a question which all of us should be asking. Like if Ghazipur is getting remediated, or if the Ahmedabad site is getting remediated, or some intervention is happening anywhere, is that site after remediation, will it be utilized as a processing site, or what will be its end use? Because the end use is a question mark right now. Would it become a dumping yard again? That's also a question mark that's also a question mark. So I think high time that our cities have landfill tax in place, where if a truck comes to a landfill site, it pays to the corporation that you're dumping, you're not utilizing your resource. So, you pay a tax, also an incineration tax to start with, because at the end of the day, these are not resource intensive technologies. You're either burning or you're either dumping, which is not sustainable. And of course, I think I've touched about this bit, so I'll skip. Of course, engagement and awareness in cities is very, very important at not just generator level, but every stakeholder needs to be mapped and needs to be a part of, the resource strategy for a city. And it shouldn't be left only to the purview of municipalities. So there has to be an integrative approach, tying various stakeholders in the city. Wherever it has worked, local stakeholders have been deeply involved, to change the paradigm for a city on waste management. And of course, living in a country like India, you can't leave behind informal sector. Many a times we are creating systems in a city which has a tunnel approach, which means you set a waste to energy plant. All right, this plant will take 3,000 tons of waste every day, but it will also take everything which is recyclable, which could have gone for processing. So then your approach with a centralized system only becomes about the numbers and the tonnage and how much quantities you can feed into these guzzling boilers. But then there is a parallel informal sector which is looking at diverting about 10,000 tons of waste daily from our cities. And how can we leave them behind? How can we not integrate them? So I think there's a lot of lacunae around integration of informal sector. We've been using the word integration ever since, and I think the word really bothers me now. We're really not involving them enough, I feel. They've been just limited to, just like picking our trash, nothing beyond that. Their capacities have not been upscaled, their skills have not been built. And of course, there are models that are doing it. But I think those 7, 8 or 10 models will not really suffice in a scenario where, the waste generation and the waste complexity will only become more and more difficult and complex. And there are various approaches to integrate them. One could be, of course, that you involve them directly into collection, and which is like in majority of the cases with the right over recyclables. So, what you could do is in a city bylaw, you could include that, the portion for recyclable dry waste would go to the informal entity. Second, and a better option would be to associate them as cooperative or a society, and municipalities could also support informal sector in establishing those cooperatives or SMEs. Ambikapur has done it and done it wonderfully. And so why can't other cities replicate the same model? And also, third is provide them with further capacity and, train them and build their skills so that they could also be integrated with several private run interventions now, which is not the case. Many of you will say that it's happening, but as someone who's been just past many years going to many cities, studying models, also implementing models on ground, I don't see this enough. There's a clear lag in integrating informal sector, and high time we incorporate them, because we can't beat the skill that they have. They can just see an element and they know what it is and where it should go. Probably they won't have a technical name for it. And that is where skill building and, making them more formal in their approach and more strengthened in their approach will help. But it's not happening enough. And last and not the least, having a systemic roadmap to transition to, more circular system. Having bottom-up approach over a top-down approach, hear it out from cities that are doing commendable work and how they have done it and how they've changed the system, and incorporate that in your policy. Also, as I said in the beginning, if you look at various rules and policies that are in place right now, most of them are not coherent with circular economy principles. So, we really need to align them with resource efficient policies, and we really need to revise them. And at the same time, focus on their implementation and compliance right now. We've been beating the drum on plastic waste management since 2016 now. Nothing much has happened. So I think a better approach of implementing a policy is also to take feedback from the ground and sort of revise it from time to time, amend the policy based on those feedbacks. Also integrate local bylaws with more sustainable circular strategies, because any change that we emphasize, it has to happen on the ground. And of course, I always say that there are 3 components that could always work for a city on waste management or around sanitation, or for that matter, around any approach which is sustainable. One is political will. One is your administrative will, which is you have a very good administrator or commissioner. And third is, citizens and their involvement. Now, if these 3 things are in place together, everything works well for a city. If any of the 2 things are also in place together, things work. But if it's either of the one, it not really falls into place. So I think it's high time that we work around these systems, and I think I've devised these 6 steps based on those practical experiences that I've had from the ground, and even presently, going to cities and seeing like what do they generate. So I think no way, this is of course not impossible, or this is not like a very flowery roadmap, but this is something which has basically all the components of practical experiences from the ground. And if cities truly implement it, we could have more resilient systems around waste management in our cities. And probably then me and Professor Dubey and all the others that are there, it's a very august panel, we won't be just giving sessions like how to, probably would be sharing like, okay, this happened there. So high time we have more best practices, high time those limited practices that are already there get replicated. Only then the scenario will change. Otherwise, we'll just keep lecturing. Thank you.
Thank you, ma'am, for your valuable insights. And now we will move on to question and answers. It is, if source segregation is the most important step towards a better waste management, what measures do you think can help to bring about an change in attitude in the waste generators as well as waste collectors?
Okay. Well, based on experience, one definitely, as I said in the session also, that in the presentation, that you need to, social engineering is something that has to be continuous. It cannot be intermittent. So of course, when you are trying to change a system for a city around sustainable resource management, social engineering has to be continuous. One way of it could be having a volunteer-based system where there is a check on segregation levels, or also going a step further and making it more AI intensive, where you develop, say, a mobile app for a city, which could track the levels of segregation, and it's daily available for the residents of a city that, okay, today, this is the level of segregation. This percentage of dry waste was segregated, this percentage of wet waste was segregated, this percentage was dumped. So that citizens, and or for that matter, generator feels like, at the end of the day, it's a consumer or a generator who's generating. So I think making waste up close, it's not in front of our eyes usually. So presenting that data and making it freely available could really work. Second thing which always works is utilizing local media. How can a city or a corporation work with local media to spread more stories around positive waste management? One way of it could be, having like ward-wise competitions, like which is the cleanest ward in a city. It could be done on a quarterly or a bi-yearly basis, so that more and more residents and generators are sort of integrated into the plan. And third, of course, is a carrot and stick approach, wherein you incentivize the ones who are doing good work, but you also desensitize, like have penalties for people who are faltering at it. Don't collect unsegregated waste. I mean, at the my first question is that if your law says, I'm sitting in Delhi, and Delhi bylaws, which I was a part of for formulating, it clearly says that every generator has to pay, has to give segregated waste. And if not, there'll be penalties, and the penalties are in place. But it's only during survection that circular floats. Well, if you're not giving segregated waste, you'll be penalized, but no one gets penalized. So I think, all these approaches will sort of work together in motivating, residents to segregate more, because clearly it can't be optional anymore. We are living in an era where if we talk about any practice, which is a good practice, segregation was the base of it. So good waste management or good resource management cannot happen without segregation. I hope I was able to answer it.
Yes, ma'am, indeed. Second question is relating to taxes. Is it possible to introduce dustbin tax in India like USA and European countries?
I'm not sure if USA has done it. I mean, anyways, if anyone quotes USA as a good waste management model, I'll highly doubt, because it's a very, it's similar, like very collection, transportation, and disposal incentive model. But yes, around Europe and Scandinavia, you know, and they have these systems in place to disincentivize generation. So this can be practiced. It's very easy to be done. I think it could be piloted out in a few cities. A bigger change would be in the bylaw of a city. And after the Solid Waste Management Rules 2016, every city had to change its bylaw as per the rules, which is quite strange, has not happened for many thousands of cities. So, you know, there's still a scope to probably bring this element into the bylaw and then sort of pilot test it. Like, you know, the less you generate, probably the less tax you pay, or the less fee you pay, and the more you generate, the more fee you pay. Or you could also tweak it around, like if you give segregated waste, you know, it will be collected, but then if you don't, it won't be collected, and give that power to the waste collector. So I think we really need to also decentralize the power. Apart from decentralizing the system, we really need to have decentralization in powers, because it's the waste collector that comes to our houses, but that fellow has no power at all. You know, if you complain it to him, he'll be like, well, I have to talk to my ward inspector and then I'll come back to you. And many a times your queries or your doubts will never be, you know, addressed. So I think I am optimistic that, you know, these tools can be implemented. I also give an example of Mangaluru, who's actually implementing it. Mangaluru has a plan to become a zero waste city, and they presently have this 50% concession if you compost your waste, and if you're segregating and composting, you pay, you know, 50% less property tax. So it's like a win-win situation. Yeah.
Ma'am, I just wanted to ask you one operationalization question, since we were discussing that. We all know that Indian cities really don't have any, you know, taxing or their financial capability, and the property tax is so low. So much so that for most part or most households of the city, more than 2/3, they don't pay any property tax.
Yeah.
And if I tell you about Delhi, people are thereafter to pay the property tax, website is not working. And, you know, so much of things, because much more of our things is carpet area based and not the real value, unlike United States or any other part of the world. How do you see in that case, how do you see the role of private sector? Because in European and other nations, when you're giving your plastic or anything, you earn a credit or, you know, some other arrangements. How do you see the role of private sector and corporates and also civil society going ahead towards that? Not only just government, but what other mechanism you and Habitat or in your experience would you like to highlight?
Well,
real estate and, you know, the state of affair there linking with just one lever property tax becomes huge administrative exercise as well, you know, quantum measuring everything. It becomes quite complex. Southern cities can really do it. They are good, well organized. But for overall,
well, as I said, it has to be an integrative approach. It can't be municipality alone. So definitely private sector, corporates, you know, and civic society organizations, they have to go hand in hand within a city. For instance, to set up a model, I mean, the awareness and you know, the sensitization part and the propagation part, it has to go to a civic society organization or a volunteer organization. But in terms of setting up systems in place, it can't be cooperation alone. It would definitely need a lot of support from private entities, from cooperatives, and you know, even you know, the big agencies that are there. As routing their CSR funds into cities. So I think it has to go hand in hand to create a system. Of course, for a smaller city, it's much more possible and less challenging as compared to, say, a city over 10 lakh population. So the moment it goes 1 million, of course, the dynamics change, the generation change, the quantums change, and then, you know, you definitely need additional support. But smaller cities, definitely at municipality level, this can be done. On the taxes bit, of course, you know, across India, it's been seen that the collection percentage is very, very low. The compliance percentage is very, very low. So I think I do agree. We really need to, say, mainstream this system, probably make it more accessible, make it more online. It's still very, you know, primitive in 2021. The way people pay taxes is still like a very primitive system. So I think it needs to become more robust and probably support from various organizations which could sort of strengthen it would really help. Also, many a times the penalty collection for not paying taxes is like not in place. It's quite faulty, which is what I was emphasizing on, that even if there are penalties, no one really cares. Everyone has a way out. So I think high time this really has to be streamlined. Yeah.
Great, great. Thank you, ma'am. Because when we interact with the administrators, they are really like, we can't impose one new tax or something like that. It feels like a burden to them. So thank you very much. And ma'am, if you can stay, we can take more questions after Sunil sir has also joined.
Yeah.
Sunil sir, can you hear us?
Yes, I can, Dr. Arjun.
Thank you. Thank you, sir. You can also have your video on. So quickly, let us introduce sir. Ma'am, please go ahead.
Now, I would like to introduce you to Professor Sunil Pandey, our last speaker for this session. He is Director, Environment and Waste Management Division, TERI, the Energy and Resource Institute, New Delhi. Dr. Sunil Pandey is Senior Fellow and Director, Environment and Waste Management Division, TERI. In addition, he is adjunct faculty. He is adjunct faculty at the TERI School of Advanced Studies. He has more than 30 years of consultancy research experience in the areas of municipal, industrial and hospital waste management, plastic waste management, waste to energy issues, impact assessment, air, water and soil quality monitoring, site assessments, performance evaluation of ETP, and institutional strengthening and capacity building. Prior to joining TERI, Dr. Sunil has worked for ERM India as consultant for 2 years, where he was working on projects related to hazardous and hospital waste management, environmental site assessments, and institutional strengthening and capacity building. Dr. Sunil has also worked as research assistant at Hong Kong University of Science and Technology on development of landfill liner for containment of land disposed hazardous waste, and University of Hong Kong on deriving material balances and associated environmental pollution for Hong Kong region as part of postdoctoral research. I invite you, sir. Welcome to IMPRI #WellPolicyLearning, and over to you.
Thank you, Nishi, for kind introduction. It was an interesting session by Swati when I joined in, and I'm sorry I couldn't join earlier because there was another meeting happening. Let me try sharing my screen. What I'll do is I'll take you to another aspect on waste management, which is hazardous waste and what happens and what are the measures and what are the approaches one need to take whenever there is a hazardous waste spill or containment or if such episodes happening. So another 30 minutes or so I'll engage you on this. To begin with, as a definition, I would like to define what hazardous waste is and why. I mean, it is little different from conventional hazardous chemical. And when we look at definitions and if you look at regulation, there are many complicated regulations as per complicated definitions as per the regulation. And this is one of the most simple one, which was actually framed in 1986 by UNEP, WHO, and World Bank. But still, it covers all the elements of whatever can be covered under hazardous waste. And by this definition, what it means is any waste, because of its certain basic properties, physical and chemical, reactive, toxicity, flammability, explosive or corrosive nature, can cause danger or has potential to cause danger to human and environment if they are not properly managed. So that's kind of a simple definition for hazardous waste. It gives you clear indication on what can be toxic and what can be hazardous waste, which we deal, especially when you look at industrial sources. And why hazardous waste is different from parent chemical. For example, if you look at parent chemical like arsenic, parent chemical like cadmium or chromium or phenol, How it is different? Because most of the hazardous waste, most of the time when we encounter hazardous waste, they're complex, multi-phase mixtures. They can be semi-volatiles, volatile, liquid, solid, everything existing at the same time in the waste which you encounter. So there's a greater complication where when you design a strategy for handling them. And all this is because of varying nature of physical and chemical properties, which we kind of discussed above also in the definition. But some of this is also because of viscosity of the waste, volatility, flammability, and compatibility of one waste type with another. Not only with of one waste type with another, but also compatibility of waste when it is stored in a container or packaging. It is very important to see if the container and waste are compatible with each other and waste can remain safely there. Some of the typical hazardous waste types which we encounter from industrial sources: cyanide waste, heavy metals, as I said, cadmium, chromium, arsenic, mercury, such kind of waste having these metals. Organic waste streams, including solvents and tars from various sources, from solvent use, refining, distilling, or from petroleum refining. Inorganic waste majorly contributed by effluent treatment plant sludge, because most of the ETPs which are designed in and operated in industry have to have a physicochemical treatment process, and that process generates a lot of sludge. Asbestos bearing waste, very hazardous, though it is being phased out and has been phased out in many countries, but there are some still legacy structures which still contain asbestos, and when they are dismantled or they are removed, the asbestos has to be managed carefully. And certain miscellaneous kind of waste, for example, a chemical can or chemical container in which these chemicals are transported to industry by the use. So once they become empty, they become hazardous waste. Containers become hazardous waste unless they are decontaminated. And things like date expired pesticides, date expired fungicides and all that essentially covered under miscellaneous waste. This slide covers what is impact of the hazardous waste when it is disposed on land, and that is that too also in an unprotected land. Unprotected land in the sense that there's no liner, there's no protection either on the bottom or at the surface. So when such waste is disposed because of precipitation, because of inherent characteristics of waste, many times they attract birds, rodents, other pests and insects. Also sometimes strayed cattle and those things if disposal site or such dumps are not protected. The waste, because of its volatile nature, gets evolved as a gas. Also because of chemical reactions going on in the disposal site, many gases can get produced and get released into environment. And when the rain comes, the soluble portion of waste gets dissolved into rainwater and can pass through waste pile into soil and finally into groundwater, which is beneath. Or on the left hand side, if you see, if there is a surface water source around, there's a potential for its contamination also. So that essentially gives you what kind of environmental hazard waste can have if it is not disposed on a suitable site. Next slide basically covers pathway for human exposure. When the waste, especially hazardous waste, if it is disposed on land, then through what routes it can expose human beings. In the end of the receptor chain, you see a human being, a man, or woman. Through evaporation, waste can go to atmosphere. Through inhalation, man can inhale it. Through its soluble nature, waste can go into water body. And if man consumes contaminated water, polluted water, the person can get affected. Waste disposed on soil can also be consumed by aquatic and terrestrial flora and fauna in soil or water body. And if one consumes that, for example, we have known historically of a Minamata Bay disease where people were consuming mercury bearing fish, and they started suddenly falling sick. And when the investigation was done, it was found out that there was a industry discharging mercury-bearing wastewater in the river, and the fish were consuming it. And fish were, by accumulating mercury, not getting affected by that, but when a human being was consuming that, it was they were getting affected. So that's a kind of different pathways, either through direct inhalation or through ingestion or through direct contact. One can also, if a person is working in a hazardous area, through direct contact also on skin, person can, or I mean through breathing, one can get affected in an adverse manner. These are some photographs which were taken a few years back on how waste collected and stored, if it's not collected and stored in a proper manner, it can cause pollution, cause contamination. The slide on the photograph on the left-hand side shows you waste oil which was stored in a drum, and you can find out there's no price on guessing that the oil is leaking, and oil has already contaminated the soil around. And at some point of time, it would move further down. And if the groundwater is not very deep, that there's every chance that groundwater will get contaminated by this oil. On the right-hand side, interesting episode, because what happens is many times small and medium enterprises, which are there many in millions in the country, when they generate hazardous waste, they don't like to send it to common facility because of the charge which they levy on disposal of waste. And many times at night times, they indiscriminately dispose the waste on the roadside. And you can very well imagine, you go to any industrial area, you'll find such episodes happening in that industrial area, if they are small and medium enterprises working. And you can very well imagine what happens when the rainwater comes. All the soluble portion would go in the soil and also affect the good groundwater. This is an interesting case. This actually is not a very new case. It happened around 25 years back, but it's kind of worth mentioning here. There was a dye intermediate company which was manufacturing dye intermediate, which is subsequently used in dyeing process by fabric industry. And this dye intermediate company was in Rajasthan, operated for a year. And it was located in an area which was pretty dry, and there was, rain used to be never sufficient in that area. But unfortunately, that particular year, when they were started operation, it was heavy rain in that area. And because of sandy nature of soil, all the sludge got washed off. And around 70 wells, groundwater sources in that area got contaminated. And since it was dye, one could immediately realize that contaminations happened. Otherwise, had it been non-dye wastewater, it was difficult to also make out that groundwater is contaminated. Subsequently, Government of India undertook groundwater remediation program, and this groundwater was remediated and rehabilitated. So from these quick impacts, we'll now move to discuss what are the relevant guidelines which Central Pollution Control Board has issued time to time, which tangentially or directly discuss some of these issues, emergencies arising out of improper hazardous waste management. In 1991, there were 2 volumes issued. Volume 1 basically was guidelines for generators regarding handling, transportation, storage, and treatment and disposal facility. So because what happened was in early days, wherever there were small and medium industry clusters, it was felt that it will not be possible for them to individually treat their waste. And if there are centralized facilities, then it would be much easier for them to send their waste to these facilities. So there was a guideline also issued for how these facilities should function. And also guideline also covers emergency procedures in case of any accident or spillage happening while handling hazardous waste, whether at the generation site or at the common waste management facility site. Volume 2 deals with guidelines for siting hazardous waste treatment and disposal facility, because these are kind of operations which are dangerous, And so in case of any accident, in case of any spillage, in case of any leakage, site sensitivity or site ecology after is always a concern. So how, these sites need to be cited. Identification and assessment of abandoned hazardous waste disposal facility. Because of, the reason which I said earlier, the policymakers found out that there are a lot of legacy old hazardous waste contaminated sites, which at some point of time will require cleanup and remediation. So there was a guideline issued for how to assess and make accounting of such legacy contaminated sites. Guidelines for hazardous waste transportation. I actually tried to find out date for this guideline, but unfortunately there was no date mentioned on this document. Guideline for storage of incinerable waste, because incinerable waste again has a lot of toxic and hazardous constituents in terms of organic material. This was issued in 2005-6 by CPCB. And lastly, in 2010-11, protocol for evaluation and monitoring of treatment, storage and disposal facilities, including incinerators, if they have incinerators also functioning within their premises, how they need to be monitored and evaluated for their performance. Because it was also felt that now there are so many common facilities, one needs to also develop protocol for monitoring and evaluating these facilities to ascertain that these are working as per guidelines which were issued by CPCB earlier. Now, from these guidelines, I'll move to if the spill or contamination happens because of hazardous waste mismanagement, whether it's collection or transportation or treatment or disposal, how to approach that. And since my early days, I have been actually working on hazardous waste, and this is an approach which is very old, prescribed by US EPA, but still relevant and followed by most of the investigators who look at hazardous waste spills and contamination and how to basically characterize them, how to monitor them, and how to address them. So to begin with, site investigation, a detailed site investigation is required to be performed on land where you suspect that there is a release or suspected release of hazardous waste has happened. The site investigation essentially is a comprehensive study of hazardous waste release with respect to relevant site condition. Relevant site conditions would mean that what is the soil condition, soil geology, if there's any water source around, if there is a habitation around. So this will, a lot of these characteristics or properties will become site conditions. Its purpose is to develop sufficient site characterization information to provide recommendation for future future activities relating to rehabilitation of site. So if there's a contamination happening, what is the size of contamination, what is the extent of contamination, whether that requires remediation or no remediation, all these decisions are taken after site investigation is carried out. One of the most critical step here is to identify sensitive receptors that are directly or indirectly affected by the release or spill. And when I say sensitive receptors, essentially it means kind of if there is a resident population around, if there's a wildlife sanctuary around, or if there is a say very close to airport or very close to a river body. So all these, their vicinity to site of spill classifies the site, whether the site is sensitive or not sensitive. If it's say in an abandoned area, maybe site is not so sensitive, but it is, if it is close to a very sensitive receptor, then it becomes a sensitive, and it also becomes urgent to handle that site on a priority basis. SI is required when there is a contamination present in soil, first condition, at the concentration which poses risk to receptors. Sometimes it's very low concentration and there's no risk to receptor. Sometimes the concentration levels are sufficiently high that there's a sufficient risk to receptors, so remediation action is required. Directly affected or threatened sensitive receptors is another criteria where you decide a site investigation requirement. suspected groundwater contamination. If groundwater contamination has happened or is suspected, then it's a very serious issue, because what happens is, unlike surface water where the water flows down, at some point the pollution or contamination will flow away. Groundwater, once contaminated, is very costly and difficult to clean and treat. So that is why this information becomes critical. Presence of non-aqueous phase liquid. What essentially it means is, when the groundwater or surface water is contaminated, there are some organic liquids which are lighter than water, for example, oil. When the oil discharge happens, oil will float on the surface. There are also something which is called dense non-aqueous phase liquid. So, for example, tar or certain materials which are heavier than water. If the spill or contamination is happening because of that, they will go down to the bottom of the water body. So this information is very essential when you are looking at site investigation, to basically direct your focus whether you need to work on surface water or go beneath and look at bottom of the water table or bottom of the sediment in the sediment. And what information is also required is what is kind of suspected release of hazardous material, whether it's a cyanide or styrene leak which happened last year in one of the chemical companies. So one also needs to have some information on what kind of waste material has leaked or has caused contamination. When you look at risk assessment is another important element of site investigation, to basically look at what kind of contamination and what is extent of contamination or pollution which has happened. And this is again looked at with respect to receptor, whether the site is sensitive or not sensitive, as I explained earlier. And how risk is defined. Risk is a function of compound's toxicity and the exposure. What is exposure dosage and exposure pathway? As I said earlier, there are 3 exposure pathways. One can ingest chemical, one can have a dermal contact, one can have a ingestion through water or through other materials. Toxicity data here typically is collected from literature because there's enough toxicity details available in the literature for most of the chemicals which are used in by industries. And such chemical databases are, for example, Merck IRIS database, and there's a information on toxicity in terms of lethal dose 50%, lethal dose 90%, lethal concentrations in different media. So such information can be taken up from standard literature. Exposure dose can be estimated by actual monitoring at the site, where you know concentration. If it's mercury, then how much concentration is available, milligram per kg in soil, or lead, how many milligrams per kg of the or grams per kg of lead is there in the soil. So dosage information is collected from there. Exposure pathways would be specific to compounds and media in question. For example, as I discussed earlier, drinking water ingestion, dermal contact, or inhalation. There are 2 approaches in risk assessment which are generally followed. One is qualitative approach, where you look at sampling contaminant concentration in each of the pathways, whether it's ingestion or inhalation or dermal, and then compare it with the risk-based values which are there. This is slightly expensive because what happens is then you have to look at expensive monitoring protocol. So if you have sufficient funds available, then only you go for such approach. Second approach is quantitative, where you look at EPA's risk assessment methodology, and there are certain models which are available with EPA, which with the basic details collected from the site, you can run these models, and they give you kind of dose or exposure of receptors, sensitive receptors to the hazardous chemicals or hazardous waste. Based on the data which is collected in the 2 processes, either quantitative or qualitative, one decides on a priority for action. Sometimes what happens is contamination is very low, or contamination is of such type that it degrades very fast in the natural environment. And you know that maybe in 6 months' time or 3 months' time, the pollution which has happened will clear on its own. So that's classified as natural attenuation, where you know that system will address this pollution naturally. You don't do anything, just wait for some time, isolate the site from various interventions, and wait for some time before the site gets cleaned, and then you can open the site again. In order of preference, you look at first in situ methods, where you can say in a plot or in a field or in an industry where pollution has happened or contamination has happened, if we can treat the contamination or pollution inside within that area itself. So that would be much easier, much cheaper also. But sometimes what happens is it's not easy to do in situ remediation. So you look for ex situ methods. For example, if there's no soil is contaminated and there's no in situ method which can be applied, then you excavate that soil from that area, take it out and treat it elsewhere. So that becomes a ex situ method. If you look at remediation methods, corrective actions, typically there are certain factors on which these remediation methods depend, how to basically select a proper remediation methods. And I'll share that slide also, what are typical treatment technologies which are available. Complexity, it all depends on complexity and sensitivity of the site. Number of contaminants which are involved, whether it is single contaminant or multiple contaminant, extent of contamination plume. If there's a air emission of contamination or ground emission, ground discharge of contaminants, then how much contaminant has moved with the water or on its own, depending on site's hydrology or site's geology. It is, if that information is available, it's very easy to take corrective action decision on that. Persistence of contaminants, because many contaminants like chlorinated hydrocarbons, they remain in the soil for a very long time. They don't degrade that fast. So if the contaminant is persistent, the remedy will be different. Other contaminants like mercury or arsenic, they are very volatile. So if they are released on soil, in very short time, they will again volatilized and get into air environment and very toxic. So you need different kind of strategy for that. Existence of single phase or multiple phase waste contaminants. And finally, local and geological and hydrological conditions. So these determine how corrective actions has to be taken. There is also guideline by Government of India, Central Pollution Control Board, on how if such spill happens in industry environment or environment in which hazardous waste is being managed, what kind of emergency preparedness action has to be taken by the generator of the waste or occupier of the waste. So first point, occupier generating hazardous waste should draw an emergency plan and for on-site storage and transportation of waste, and do time to time drill for emergency preparedness to know that they can handle any emergency arising out of that. Emergency plan should address minimizing hazard to human health and environment from episodes like fire, explosion, any unplanned or sudden release of hazardous waste, or hazardous waste released to air, water, soil, and surface waters. Now, the person who is transporting the hazardous waste is also very important in duty to ensure that no accident happens, no spillage happens in the transportation. So they should be basically made aware of a kind of hazard which will happen. For example, if volatile waste is released, then what corrective actions has to be taken. If something which is soluble in water gets released, then what kind of action has to be taken. If fire has happened, then what kind of fire extinguisher he has to employ, because normal fire extinguishers are not used for chemical emergencies. Precautionary measures to be taken in case of emergency, and these measures are recorded in something which is called TREM card, Transport Emergency Card, and every transporter of waste should have this TREM card readily available. What is the emergency number on which he should contact? What is a local police station or local those numbers where he should contact, and so that remedial measures can be initiated immediately after the emergency has happened. This chart actually gives you compatibility of hazardous waste. because as I said earlier, hazardous waste, different kind of hazardous waste need to be compatible not only among themselves, because if they are stored in the same place, they should not start reacting with each other, but also with the container. So this essentially tells you what kind of waste is compatible with what other kind of waste, and if it's not compatible, then what kind of impact it can have. For example, E, wherever E is written, E is explosion possibility, F is fire, GF is emission of flammable gases, GT is emission of toxic gases, not flammable but toxic gases, H is heat generation, S is solubility of these materials into water, so that there's the toxic waste material can get washed off. And you look at 1, 2, 3, 4 numbers. So for example, if you look at 4 and you look at blank, what it means is 4 is compatible with 4. But interestingly, if you look at say for example 6, 6 is compatible with many waste types, like 6 is compatible with 5, 6 is compatible with 4, 6 is compatible with 3. These numbers are there. And 6 is not compatible with 2. And what is a hazard? Solubilization of toxins. So like this, you can, for every waste type, starting from oxidizing material, caustics, aromatic hydrocarbons, halogenated material, you can find out which of these are compatible with which of these types of waste. Because in industry, you generate different type of waste and they need to be stored till they are transported for disposal. And that storage should be in a manner that they don't kind of interact with each other and cause a problem at the storage site. These are kind of PPs which are supposed to be used by people who are handling waste. And if you look at this, this is divided into 4 levels. So if you are aware of what kind of hazard your waste is going to pose, you can accordingly select these kind of PPs. Level D is most relaxed and level A is most strict. And what is suggested is, if you don't know anything about the waste disposal site, if suddenly a leak or pollution or contamination has happened, then you start with level A, most strict. And once you know more about the waste, if there is a need, you can go on relaxing your PPE requirement. Because what happens is, if you're working at the site and suddenly you get exposed to something, even mortality can happen because of very toxic nature of waste which you're handling. So it's always advisable to start with most strict PPEs. And then as and when you have more information about the waste, you can go on relaxing the criteria. There's also discussion on suggestion on what kind of gloves one needs to handle for use for handling various kind of hazardous waste. For example, butyl rubber can be gloves made of butyl rubber can be used for handling aldehydes, carboxylic acids, and chemicals like that. Latex generally is not used in handling hazardous waste. Neoprene can be used for handling mineral acids, oils, plating solutions. And these are kind of labels which are very important to be placed when you store hazardous waste or transport hazardous waste. You often must have seen many of these labels placed on hazardous material being transported in tankers. So either ignitable, flammable. If flammable, then what kind of extinguishers should be used. So such kind of labels also is very important to be used so that in case of any emergency, proper action can be taken up. This is a summary of some of the remediation technologies. And as I said earlier, when the contamination pollution happens, some of these technologies can be used in situ. Some of these technologies can be used ex situ. And some of these technologies also, if pollution has happened in large amount and some resource recovery is possible, then the first column is basically technologies which are used for resource recovery, skimmers. Let's say, for example, large amount of oil leak has happened from a tanker and somehow of this oil can be recovered. Then you can use vacuum trucks, pumps, different kind of extraction and recovery options. If the material is easily degradable, then you can use landfilling or land farming or even simple bioremediation or composting for addressing the pollution. If the soil is contaminated by volatile material, then soil vapor extraction or bioventing can be used as a technology. For groundwater contamination, If the groundwater contamination is large and groundwater has to be treated, then easiest way is start pumping the groundwater out, treat it, and then either release it back into the aquifer or use it for some alternative uses. Similarly, there will be areas where contaminations happen, but it's not a sensitive receptor. It's not close to any habitation. So you can just kind of make a slurry wall or containment wall and isolate that area so that it doesn't come into contact with sensitive receptors. So these are kind of summary of action treatment technologies. Since time is less, I'm moving a little fast. So let me know if you want any more information, any of these. What we have done is in TERI we have environmental biotechnology division. So I'll present a quick case study on how one of these technologies, which is called bioremediation, was used in addressing the chemical contamination. So what happens is most of these oil refineries, petroleum refineries, they generate a lot of oil sludge because in the tankers they store oils, and because of the impurities, a lot of sludge gets generated over the period, and the sludge becomes a problem later on for disposal. So they were looking at technology which can be used for remediating this, because earlier they were storing them into pits, and suddenly after a few years they realized that they are running out of these pits and they need to have more such pits. One option was that you clean out the sludge and then make use of that pit again for storage of sludge again. This is kind of property of this oily sludge in terms of acceptable oily sludge in total petroleum hydrocarbon, around 28%. Sediment, sand, silts, large amount, 28% again. And if you look at total petroleum hydrocarbons, most of it is basically saturated hydrocarbon fraction. Why this characterization is required? Because that helps us selecting correct type of bacteria or bacterial consortium which can feed on these. So what we did was, when this project was given to us, the R&D team, they went to various oil refineries, they collected the soil samples from there, and they started extracting bacteria from there. And using these bacteria, testing them in lab, finding out their efficacy in degrading and utilizing this waste material as a source of carbon. Our biotechnology lab formulated a kind of consortium, which we call oil zapper consortium. And this figure clearly shows you on the left-hand side the sludge pit which was given to us at the time when we were doing bioremediation. And after 9 months of our bioremediation study, the same pit, if you can see, all the oil sludge has been eaten away by the bacteria, and soil is restored almost to normal condition. So with this, I'll end my presentation here. And thank you so much for your patient hearing, and I'll be open for the question answer session.
Yes, sir. Thank you for your valuable insights. So I would like to ask a question. Since effective post-disaster debris management hinges on an effective pre-disaster planning, what measures can be taken in that perspective?
See, pre-disaster, the most important aspect is your emergency preparedness, because wherever one stores hazardous waste, storing of hazardous waste is more or less similar to storing of hazardous chemicals, like you store HSD, you store caustic, you store sulfuric acid. Most of the chemical industries routinely store these into their premises. So storing hazardous chemicals, because the properties are similar, and not only similar, because it's more complex because it's multi-phasic, multi-component mixture. So same kind of requirement is there, safety requirements, and same kind of emergency preparedness is required for handling hazardous waste as well.
How important it is to develop guidelines for each type of disaster and making reasonable plans for how to dispose each type of waste?
This is actually a difficult task, because we are dealing actually with wastes. If it's a single kind of waste, then it's very easy to design a guideline around that. Say, for example, if industry is generating only mercury bearing waste, and mercury being volatile and extremely poisonous, you know that even a small amount of mercury going to water body will contaminate entire water body. You can design guideline, and you can design remedial measure or preventive measures for mercury management. But if it's a waste, because I mean, in industry, you deal almost every type of waste in a typical chemical industry. So there has to be guideline which is overarching and based on properties of the waste. As I said earlier, toxicity, reactivity, flammability, or corrosivity. So whichever is the prime property of the waste, based on that you design remedial measure. If the toxicity is the matter of concern, then accordingly you design. Otherwise, flammability, if the material is flammable, tendency to catch fire, then you design your remedial measures according to that.
Yes. What is the best technique for final treatment of waste for small and medium cities where the calorific value of the waste is low? The second question is, what are your thoughts on communicating sustainable solutions or even policies to the general public?
The first question is for the smaller cities. In this context, actually, I was only discussing about hazardous waste generated from industries. Probably your other speakers might like to answer that. But there are technologies available for recovering energy from waste which has some calorific value. And if it is not high in inerts, then it can be, say, converted into something which is called refuse derived fuel, which essentially increases the calorific value of your waste to a level where it can be gainfully used by, say, other industries for fuel use or by cement kilns for as a source for power generation.
Yes, sir. And the second question was, what are your thoughts on communicating sustainable solutions or even policies to the general public?
Actually, if you're looking at hazardous waste in this context, it's most of the time chemical problem, and we have been using chemicals which are not green, not something which is not which cannot be handled without proper care. So, in a longer run, adoption of green processes, adoption of processes which reduce our chemical footprint in terms of reducing our hazardous chemical requirements would ensure that we kind of don't need to manage that hazardous waste. Because if you look at waste hierarchy, reduction is one of the first priority. So look at ways and means to reduce hazardous chemical use. And once you have successful in doing that, you'll ensure that you're generating less and less hazardous waste and your operation will become more and more sustainable.
Yes, sir. So there is a question regarding hazardous waste. If silica gel comes under hazardous waste, and as it is not categorized under hazardous waste management rules, and in case of yes, whether orange silica gel can be replaced with blue silica gel?
Silica gel per se is not a hazardous waste, but if silica gel is used for cleaning as a cleaning media, or as a treatment media of hazardous waste streams, then the exposed hazardous waste or used silica gel, if it is high in hazardous waste, then it will be treated as a hazardous waste. But per se, it is not hazardous waste.
So here is a question about cities. Can the concept of green industries reduce the hazardous waste in cities, and how effectively it can be implemented?
It is actually the only way out of the way to reduce your chemical footprint. What has happened, if you look at industrial development through years, what has happened is most of the developed countries, because they could invest in cleaning up environment, they shifted all their dirty chemical industries to developing countries. And developing countries, as a result, started having these and started having problems. Once we also develop, the focus would shift towards doing more research and develop research and reducing our hazardous waste requirements, hazardous chemical requirements. And that's how one can move from getting rid of, that's how one can get rid of hazardous waste in a longer run.
Yes, sir.
Great. Thank you. Thank you. Sir, it's not a question, but more of a suggestion, because many people are also asking that what would you suggest going ahead in this new normal third wave, other things are also coming. And since our focus is on disaster resilience, what would you suggest for research and advocacy and getting the materials? And there is also changes in policy. And sir, you also head the department and be there in all the places. What would you suggest to all the training participants where to look for?
One is, I mean, if I look at the context of the presentation, one simple suggestion would be to ensure that resource recovery and recycling from the hazardous waste, which we cannot reduce otherwise, can be maximized, and there needs to be policy support for maximizing an incentive structure for maximizing resource recovery and reuse, because ultimately these go to the incinerator system or landfill site, where I mean they're not even if in the secure landfill site. I mean, if you look at regulation, it has to be kept for 50-60 years, and there's no solution. So you have to keep that site covered and keep it secure for eternity. So one needs to look at how, I mean, one needs to look at, one needs to do a kind of R&D and research and development, which can basically find use of such materials. Interestingly, one example which I can immediately give you from the news in the morning, where, I mean, you know, we use and we are going to use a lot of storage batteries in future. We use a lot of batteries in our cell phones, laptops, also the EVs which are going to come. And the minister, transport minister has given a call for making low-cost indigenous batteries in the country. Low-cost indigenous, but also it is important that these batteries don't contain hazardous material, because in the end, when they become waste, it would be difficult to recycle and recover resources from them. So one needs to focus the research on such direction, where regular material, usual material which we find in nature can be used for such applications, which at the end of life is easy to dismantle, easy to recover, easy to recycle.
Thank you. Thank you so much, sir, for joining this evening. And we will share the PPT and other things on our event page. So with that, thank you so much, Sunil, sir. And with that, we have come to the closing of the second day. So Nishi ma'am, why don't you give the...
Yes, sir. So with that, we have come to the closing of day 2 of our 3-day online certificate training program on disaster resilient waste management for sustainable spaces, jointly being organized by National Institute of Disaster Management, Ministry of Home Affairs, Government of India, in collaboration with IMPRI, Impact and Policy Research Institute, Center of Environment, Climate Change and Sustainable Development, New Delhi. I would like to propose a vote of thanks to our eminent panelists, Dr. Brajesh Dubey, Mr. Swati Singh Sambyal, and Professor Sunil Pandey for their valuable insights and knowledge sharing on various areas related to disaster waste management, along with measures to handle it in order to move forward towards more sustainable means. I would also like to thank Professor Anil Kumar Gupta, Head ECDRM, NIDM, New Delhi, and all the participants present here. Thank you so much, everyone. We look forward for the last session, which will be starting tomorrow at 10:30 a.m., having very distinguished panelists like Professor Jyoti Parekh, Executive Director, Integrated Research for Action Development, Professor Prasad Modak, Executive President and Environmental Management Center, Dr. Rachna Arora, Team Leader, Circular Economy Solutions, Preventing Marine Litter, GIZ, India. Looking forward to meeting all the participants tomorrow. Have a good day and be safe. Thank you.
Thank you very much, everyone.
Thank you, sir. Thank you so much.